All right, guys, in this video, we are going to talk about how to use completing the square with ellipses and use it to write the equation of an ellipse in standard form if it's not already in standard form. If it's looking like this kind of guy, it's pretty intense, right? The center is not going to be at the 0, 0. Then it can be a little bit more challenging to do that. So we are going to have to use completing the square to be able to solve that. Okay. And so, yeah, this is just how to do that. So in this problem, what we will see is you will see that you will need to complete the square with both x and y. I'm going to try to label my steps as I go. We may only go through this part A, just my video making time is a little limited this today. So we may just go through this part A and get a nice little detailed way how to do this. But yeah, we'll just see what I've got time for. So first thing I'm going to do is we're going to group together our x's, group together our y's, and I'd move my constant to the other side. That's always how I've done these. So I'm going to start off and I'm just going to put my 3x squared, and I'm going to put my minus 12x right next to each other. We've got this plus 5y squared, and we have plus 30y. And then again, I'm moving that constant over that 42, so minus 42 on the other side. So what we did in this step, and I'll use a different color here, but in this step, what we did is we grouped our x's and y's, and we moved our constant. Okay, so that's always how you're going to want to get these going. Group x and y, move constant. Awesome. Okay, so next thing we're going to do is you can even kind of group them by putting parentheses around the x's and the y's. That's even a thing you could do to kind of help be like, okay, this is that section, right? But the next thing we have to do is we're going to have to work towards completing the square with each one. And if you recall, we do want to, when you complete the square, you want your leading term for that to be 1. It's going to make it a whole lot easier. So the way I'm going to do this is I'm going to factor out a 3 from this little binomial. So we're going to have this as 3x squared minus 4x. I'm going to factor a 5 out of this next one. So we'll have 5 and then y squared plus 6y. And we still have this minus 42 on the other side. So factor. We'll just say that's what that was. Not exactly the GCF from each one, but it was like the leading coefficient. Okay, now here comes the completing the square part. We need to take half of the linear term, square it, add it to both sides. So half of 4, square that. So half of 4 is 2. 2 squared is 4. We're going to add 4 right there. Over here, if I take half of this term, that's 3. 3 squared is 9. Add that here. Now, what I need to do is add an equivalent on the other side. So here's the thing that you got to watch out for. Technically, I didn't just add a 4 right here. It looks like a 4, but that 4 is being multiplied by that 3. So technically, that was a 12. So what you can do is you can look at it and say, okay, well, I added 4 times 3. If that helps, say, okay, I really added 4 times 3 right there. And over on this side, we added 9 times 5. Okay, so if it helps to write it in that way, now this step was just completing square. And that's for both x and y. But those are the values that we will be adding to this side, because technically that's the values that were added on the left. We're going to rewrite this. I'm going to say x squared minus 4x plus 4. And then we have plus 5 times y squared plus 6. Whoop, I'm running out of room before my little dash line. Doesn't matter. And we say equals, and we have that negative 42, 4 times 3 is 12, so we're going to say plus 12. 9 times 5 plus 45. Okay, and this is just simplifying. That's all this step was. So we don't even need to really worry about writing that out. The next thing we're going to do is go ahead and factor these guys. So this one, this should give us x and x. Numbers that multiply to be 4 but add to be a negative 4 should be both negative 2. Again, if these don't match, we've done something wrong. Completing the square should always result in matching binomials. Over here, same situation, but with y's. And I'm thinking things that multiply to be 9 but add to be 6, that's going to be a positive 3 and positive 3. Again, if those didn't match, something would be wrong. We can go ahead and combine this. Negative 42 plus 12 plus 45 is going to give us 15 on this side. And all this was, and we can, this is just factoring, and if you really want to put a label with it, we're just factoring. Here I can simplify it to write it as my little binomial squared. Makes it look a little prettier. That's just simplifying it down a little. Now, this is not in standard form. If you recall, standard form is supposed to be equal to 1. So the easiest way to make this equal to 1 from where I'm at is to divide through the whole thing by 15. Okay, so we're going to say divide by 15, divide by 15, divide by 15. Okay, and in doing that, these guys are going to cancel a little. 3 goes into 15 5 times, so we will have x minus 2 squared over 5. Over here, 5 and the 15 will reduce. Okay, so this will be y plus 3 all squared over 3. 15 divided by 15, 1. And again, this was just simplifying. There's our equation. All right, I have about 11 minutes left, so I think I've got time to do one more. Give us one more little example. So this is example B. We're going to do is very much the same process, but I'm not going to break down each one with like, this is what we did, because you have that on that last one. Okay. All right, so on part B, the instructions were the same. Rewrite in standard form using completing the square. So let's do it. If we were to complete, or if we're trying to do that here, we need to first get our x's together and our y's together, and then we need to we need to go through that process, right? So here we have, let's just put our x's, 4x squared minus 32x. Then we have plus y squared plus 16y, and then we're going to move that constant to the other side, so minus 24 over there. Okay, again, you can do the thing where you kind of go ahead and view these as like being grouped. Okay. And then just take out their greatest common factor, or not greatest common factor, but their whatever the leading coefficient is, we can factor that out. So here I'm factoring out a 4, and we'll have x squared minus 8x. On this one, I don't really have to do that at all because the leading coefficient is already a 1. So I'm not going to bother. I'm just going to rewrite it. And we have this negative 124 out here. Now we're going to do our completing the square. Take half of your linear term, square it, add it on both sides. So half of 8 is 4. 4 squared is 16. I'm going to add 16 right here. Over here, half of 16 is 8. 8 squared is 64. All right, now we've got to talk about what we're adding on both sides. I've added over here quite a bit, but what am I adding over on the right? Well, if I added 16 here, it technically wasn't a value of 16. It is 16 times 4. So I need to add 16 times 4 on that side. Over here, this was 64. There was nothing out here to really worry about multiplying that by, so just adding 64 straight away. Okay, so when I'm adding my values here, we want to make sure that we are keeping it balanced completely on both sides of the equation. I think that was probably one of the things I remember from pre-calculus in high school. I think I remember struggling to remember that key thing where you had to multiply it by that thing on the outside. I don't know why. It's just harder to remember, I guess. 16 right there. So here I'm just rewriting it. And over here we've got, not plus, but equals, my bad. Okay, we got our negative 124. We're going to add 16 times 4, which is 64, and another 64, right? So we're adding all of that together right there. I can go ahead and factor this. Now, if you're comfortable with doing the shortcut here, you don't have to break it in. We know from completing the square that these binomials are going to match. So you're thinking what multiplies to be 16 but adds to be a negative 8? That's going to have to be a negative 4 and a negative 4. So we know they're going to have to match. You might as well go ahead and make a little shortcut there. It's a perfect square trinomial. It was made that way on purpose. All right, here, if I were to factor this, I'd be thinking, okay, what multiplies to be 64 but adds to be 16? That's going to be 8, and both of them would match, 8 and 8, right? On the other side, we've got negative 124 plus 64 plus 64. We end up with 4 on that side, which is still not in standard form until I go through and divide by that 4. So I'm going to divide everything by 4, just like that. It's kind of cool on this piece right here. That cancels out completely. So this is just x minus 4 squared. Then on the other one, I have, it is going to stay looking like that, y plus 8. There's nothing that cancels there. And then that. Now there's one more thing here, actually. It's not quite in standard form yet, even though it looks like it might be. Remember how we talked about the fact that in order for it to be in standard form, we put the term with the what would be a squared. Sorry, my word's not working. With what would be a squared, that needs to go first, and a is always bigger than b. If you look at this, this is technically over a 1. Well, which one of these is a bigger denominator? That one needs to be written first. So I'm going to rewrite this with the y plus 8 squared over 4 first, because that is showing me my a squared. That was the bigger value. And then on this one, x minus 4, I don't need to write the 1 on the bottom unless you just like seeing that to be really obvious about that's what my b is. Anyways, this is good. Most simplified form of keeping that in standard form. So, all right, that is it for 6.4, guys. We are getting close to being done with all of this. We do have one more topic left, which is hyperbolas, and we will get into that in the next video, and I'll see you then. All right, bye.